All right, it's time. Mm, I posted a link at the chat, and you can take a look. I forgot to share last time. Recently, there was a breakthrough done by Google using artificial intelligence to solve the problem of the protein structures. Okay, so if you're from biology, this is actually a very big news. So you should read it. All right. Um, any questions from the homework, Julia?
I just had 5.2, number 16, just the second part.
5.260. Mm-hmm. 16. All right. This is a classic question, so I'm assuming the first part is okay.
Yeah.
Then the second part is going to be okay. So the key here is number one, using the property of integral to change everything to be like this. Okay. The second part will be the first. Notice this is the same as this, except you switch the starting and ending points. So if this is -5, this is going to be +5. Second, for the second part, you're basically taking the integral from some interval for a constant. And a constant basically give you a rectangle. So all you need to do is use 10 times the length of the constant, the length of the interval. And you always use the ending minus the starting. And that's how you do 16.
Thank you.
Austin.
5.4, problem 9.
Number 9. All right, we have, okay. So, you want to do the integration, but your thing is piecewise defined. Okay, so, and it's quite easy because every time you have an integral, you can split it into whichever way you like. And once you split it, you will know which formula to take, depending on which interval you have. Together, you got 0 plus ln 8 minus ln 1, which is ln 8. Okay, and judging by the graph, it's not hard either. So you basically have a graph on here, and then on here you have different formulas. Then what you do is you just split them. On the left, you use one formula. On the right, you use the other formula. All right, Emma.
5.3, number 5.
5.3, number 5. Integral from there here to, okay. Gx equals minus 5. So I'm just going to change it to be 4 plus 5x. Okay, like we said, number one, always see the standard thing. This is x. Then now for gx, all you did is you changed your x to be 4 plus 5x. Now if you take the derivative by the chain rule, which is put this into here times 5. So that will be the final answer. Okay, so the key is, I would say, write down the standard one and try to see how your problem changed the standard one and just make those changes. Okay, Jordan.
Yeah, can you do 5.2 number 7?
Seven. Ho ho. We have done this for a long time, so I will just write down the answer quickly. Okay, you copied it down and try to see where you have questions. Okay, right endpoint. So what we have is delta x equals 3 minus 0 over n. Xi equals 3 over n times I sum Rn. I from 1 to n. And 3 over n times f xi, which is negative 4 3i over n square plus a 5 4n square 9i square plus 5. Okay, the rest will be just try to sum everything together. So we have part 1, part 2. For part 1, you have 27 1 square plus 2 square plus 3 square. Oh. Plus n square. Now you use the formula given by Weberg. 36 3n square plus n divided by 6. Okay, which is 9 over 8 n cubed. That will be the first part. Now for the second part. For n times. So, together. This will be Rn. And this is what they mean by a closed form. All right. If that is okay, the last thing is try to let n goes to infinity for the limit. And I don't have the room to do that, but basically it's just 18 over 8 plus 15 as n goes to infinity. And try to simplify here. Okay. Once again, we have showed that Riemann sum is a pain in the butt if you just want to do the calculation. That's why we need the antiderivative. That's why Newton is great. That's why Leibniz is great. So we don't have to do this web work. Okay. Aaron?
5.5, number 14, please.
14. Dun, 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 dun. All right. So at first glance, I see sine, I see the derivative of sine. Beautiful. A second thought, well, this will be u, one cosine will be gone. I still have this left, and I don't know what to do with the cube. Second thought, well, not only cosine is the derivative of sine, sine is also more or less the derivative of cosine. So that may be a hint. It's not sine, but it's negative sine. And negative is easy to handle. Then u cube times negative du over dx times dx, so they cancel. That is great. X. Okay, so first thought, sine, cosine, but then switch them, cosine, sine, it worked. Okay. Okay, Anton?
Yeah, so when you're doing use substitution and you are using like let's see, what was I trying to say? When do you know when to use the absolute values when you're using natural logs? Is it always or no?
Are you asking this?
Yes.
And when should you use absolute value and when should you not?
Yes.
Is that what you're asking? Okay, always use the absolute value.
Okay.
Yep. The only case you see when something is not using it, I guess it's probably coming from here, this question. Because if you do it, the final answer is going to be right.
Wait, that was the correct answer though.
That was the correct answer. That's what I'm trying to say.
Oh, okay.
So the reason is because when you try to do this, that's equivalent to ln absolute value of u. So you do have an absolute value when you do this. However, this comes from the original problem. You didn't get it from taking the antiderivative. That's why this one doesn't have one.
Oh, okay.
Sounds good?
Yeah.
Because technically during the whole process, you never took the antiderivative of 1 over x.
Okay.
Right? But once you take the antiderivative, then definitely absolute value.
That's when the absolute. Okay, sweet.
Yeah. So this one has an absolute value because you get it from taking the antiderivative of 1 over u. But this comes from the original problem, and there was no absolute value, so no. So the answer is, in general, always do this. Okay. Just like sometimes, even if you see some answer like this, right? The only reason sometimes I don't give you the absolute value is because this one is always positive. So that sometimes we skip that and we say, hey, we don't put absolute value there because it's not necessary. Since I'm handling some, like, for example, there's no point for me to write things like this, right? You know it's ln3. So be careful there. Okay, Aaron?
For web work, how do we put in absolute values?
Bar.
Bar? Okay.
You know where bar is? If you use a standard keyboard, it will be...
Yeah, I got it.
Oh, okay. Yeah, well, the first time when I learned typing, in China, we don't use bar that often. So it took me probably 2 or 3 years to realize there are some symbols there which I never typed on my keyboard. So it took me a while to actually understand what all these keywords means. Oh, all right, all right. Any other questions? Okay, next week you have test 4 due, you have the 3 writing projects due, and you have all the web work due. So make sure that you start early. Okay, hopefully we will finish all the lecture before Wednesday. So there's no class on starting from Thursday, or maybe even starting from Wednesday, depending on how fast we can finish everything. Okay, so you have plenty of room to do this. Just start early. Don't wait until the last day. Otherwise, you have too many things to do. Okay. 3 more sections, and we are done. 613, cylindrical method. So volume by cylindrical shell, which is very, very easy. So it's quick. The idea is quite simple. What's the volume of this cylinder if we remove another cylinder in the middle? Well, we have learned everything so far. We just cut them horizontally, right? Okay, so what are you going to receive? You receive a lot of washer. Now what you do is you just sum all the washers together and you let n goes to infinity. The sum become integration. That's what we did before. Okay. Now we want to take a detour and use your life experiences. Once you see something like this, what reflects to your mind? In your toilet, bathroom, that's toilet paper, right? How do you check the volume of the toilet paper? You just unwrap the whole paper towel, which give you a long thing. How to say? A long rectangle, right? And with a little bit thickness. So now if you just add all the wraps together, you will have the volume too. So that's another method of doing volumes. It's called cylindrical shell. Can you guys still hear me? That's my iPad. All right. Okay. Cylindrical shell. So this is what we mean. Okay. You take this thing again. Now you cut it vertically. And meanwhile, you don't just cut it like a piece. You actually start to unwrap it. That would be the word I want to use. Then each piece you have is going to be something like that. It's not exactly a surface of a cylinder because that thing does have a thickness. And this is what we call a cylindrical shell. It's cylindrical, but it only has a shell. Sounds good? You go closer and closer to the center, the shell becomes smaller and smaller and smaller. Okay, and then it becomes bigger and bigger and bigger as you move forward. Now what you want to do is you want to sum all these cylindrical shells together. And of course, when you let n goes to infinity, this becomes integration. So far, so good. Now the only problem is, how do you find the volume of a shell? The same idea, like how do you find the surface of the wall of a cylinder? You cut it. You cut it and you flatten it, then the whole thing becomes like this. You cut it, you unwrap it. It's almost like taking a dinner roll, a very thin dinner roll, and just unroll it. Okay? technically you should not have something this regular because the one inside will be a little bit smaller than the one outside. Right? Okay, but when you take things to be super thin, this roughly is a very thin sheet. And for sheet, I mean, I call it sheet. Basically, it's a cube, right? So all you need is the base times the height. What's the height? The height is delta x. What's the base? If this is h for the cylinder, this is r, the radius for the cylinder, then this is going to be 2 pi r when you unwrap everything. And this will still be h. So the whole shell is going to be this. 2 pi r h times the height. Sounds good? Take n to the limit. You have the formula. Done. A to b, 2 pi r h dx. So that's the formula for cylindrical shell. Of course, you have another one for dy, but really, they're just the same formula. So starting from now, we don't write both formulas. All right. Sounds good? Let's try some examples. Always test with something you already know. We have done this before. Okay. This region, rotate it by the y-axis. Okay. With that in mind, do you remember what we did before? We do this, we take this, we rotate, then we have a disk. We sum all the disks together, right? This time, let's take a detour. Rotate it. Can you see we have a cylindrical shell? Okay, for that case. Okay. Radius of the shell. Height of the shell. Finally, write them in terms of x. And this shell is going to be the y on this line. Therefore, it's going to be 1 minus x. Okay, the computation is not important, just to let you see the final answer, which is pi over 3. Now, according to what we know from geometry, it's 1/3 2 pi r squared times h 1 1 1, so you should have pi over 3. So this one is the right answer. Sounds good? That's a cylindrical shell. From here, can you see that in order to get something cylindrical, you cannot have any kind of volume. Your volume has to be generated by a volume of a revolution. It has to be from the rotation. You cannot do a pyramid in this way. Good so far? Okay, so the second case, I want to add a comment here that is only works for volume of revolution. Anything else, it won't work because you do have a cylinder here generated by rotation. Okay. All right. Example 2. Y equals x squared rotated by the x-axis. All right. How do we do it? We take this, we rotate. We have washers. Now, D-tool. Take this, rotate it. So you have cylindrical shell. The first shell, the second shell, the fifth shell, whatever, the thickness is given by dy, not dx. Then it should go from 0 to 1, which means the bottom to the top. Your job is try to figure out R and H. Okay. Well, let's draw it. Can you see this is R? And this is H. So R is Y. And Y is good because I'm doing things in terms of Y. So I don't have to change anything. H is going to be the difference between two things. The parabola minus the straight line. Okay? The parabola come from here, but I do want everything to be in terms of Y. The line come from here, but I do want this instead. So the whole thing becomes this. Make sense here? Okay. That's the cylindrical shell. Nothing more. So the key here is actually you just cut things. Okay, depending on which way you rotate it, which way you cut it. Sometimes you got a washer, sometimes you got a cylindrical shell. You use different formers for each. Both of them give you the same answer, but sometimes one is easier to integrate than the other. And we don't know it until we do it. So if you do it one way, you do it in the washer, you find this integral is impossible. Then maybe you can take an alternative and try the cylindrical shell. Sometimes it will be easier that way. Okay, no guarantee. No guarantee. All right, let's try one by yourself. Take this region. Okay, rotate it by x equals 3, so this. find the volume. And for this one, you try both method. You try the washer, you try the cylindrical, so you can see the difference. Okay, take your time, give it a try. Feel free to check my work. Let's see if you have any questions. All right. Which one is better for this case? Which integral would you rather do? I personally prefer this. Number one, 2 is better than 8. Since we have cube and the cube root is something, I don't want a big number. Second, we have cube compared to cube root. I think cube root is easier. A cube is easier than cube root. So personally, I prefer this one. Okay. So you see, sometimes one method is better than the other one. That's the reason why we need cylindrical shell. Otherwise, anything volume by revolution, you already have Washer's method. Why bother? Sometimes the integral is easier in this way. Okay. Are we good on this example? The last one for fun. The donuts again. You still have the notes from last time where we did it by washer. This time we just want to show how to do it by cylindrical shell. Okay. You take this one, you rotate, you have a donut. Okay. Mathematical term is actually called torus. That's the beauty of mathematics. You don't differentiate between bagel and donuts. You call them all torus. Okay, just the shape. Shell. This will be the shell we're looking for. Okay. This will be the radius. This will be h. So your r is just your x, your h come from here. Which means for this circle, the top half is this. The bottom half is this. So together, it's going to be this for your h.
All right.
Personally, I think I prefer the washer's method. I don't even know how to do the integration of when you have a square root. Okay, so definitely this way is worse than what you have for washer's method. In calculus 2, you will learn how to do this, and if you're interested, what you can do is you can do a u sub. If you subscribe, substitute x minus 3 to be sine u. So if you want, you can do it for fun. But it's not our concern here. All right. That's all for 6.3, cylindrical shell. I think the idea is pretty straightforward. You just need some time to do some homework, okay, in order to get used to how to set things up. Okay. Any questions before we move on? We have 6.4 work and 6.5 average value. And then the whole semester is over. Okay, so 2 more sections to go. Ideally, we should finish everything before the end of Wednesday's class. So after that, you still have another week until the last day of class. And basically, all the classes will be canceled. We don't have anything more to cover, except you can ask me to show up because all my times are free during the class time. Okay, so except you can actually send me an email and say, Dr. Chen, I have some question or something like that. I can always be there to answer your questions. Okay, so that's roughly our plan for the next, I think it's only 1 week. Yeah, next Wednesday to the Wednesday after next. So for that reason, let's stop today. We don't have to rush. Okay.